All right, happy Friday. We've got a free response question here on rates of change that we'll be going through. So the objective is to interpret integrals and derivatives involving rates of change.
Yes.
So I've got two rates related to an amusement park. This first one, E of t, is the rate at which people enter the amusement park on any given day. And the second one is L of t. It's the rate at which people are leaving the amusement park at the end of the day. So at any time, E of t is how fast people are entering the amusement park, and L of t is how fast people are leaving the
Faster.
amusement park, both measured in
Okay.
people per hour. So they're both velocities, they're both rates of change in people per hour. And the functions are valid from 9 to 23, so those are the hours when the park is open, from 9 a.m. to 11 p.m. At 9 a.m., there are no people in the park. So first I want to know how many people have entered the park by 5 p.m., and then round the answer to the nearest whole number. Junho, how could I set this up?
Entered E. The E of F. The E of 17.
If I just plug in 17, that'll tell me how fast people are entering the park at 5 p.m.
Oh, right. Oh, so we integrate 0 to 17.
Close. Really close. So not 0 to 17, but what time to 17?
5.
5 p.m. is 17.
Or 9.
9, there we go. So when the park opens until 5 p.m. of E of t in terms of time. Okay, so if we do that, okay, I think in order to keep these all in my calculator so that we can use them for formulas later, I'm going to type them into y values. So this y1 will be E of t, and then y2 will be LT. So this is
Okay.
15,600 divided by, I'm going to throw a parenthesis here, this is t squared minus 24t plus 160. Okay, then y2 is 9,890 divided by t squared minus 38t plus 370. Okay, then I'm going to quit out, and we're going to do this integral for this one. So this is math 9 for integration, and we're going to integrate et, so that's variables, y variables, function y1, in terms of x, from 9 to 17. Okay, 6004.27. Okay, I can't have 0.27 people though. So where should I round this to?
6004.
6004, perfect. So we could say 6004 people entered the park by 5 p.m. Okay, any questions on part A?
No.
Okay, then Oliver, over to you. Our price of admission to the park is $15 until 5 p.m., but after 5 p.m. the price of admission goes down to $11. I want to know how many dollars were collected from admissions to the park on any given day.
Let's Lead is stuck again.
Leah's stuck again. Okay.
Hello?
Hello, can you hear me?
Yeah.
Okay, cool.
Okay, wait.
If the video gets stuck, you can use the document to follow along. So we're on part B right now. I want to know what the setup would be.
Okay, what is okay, loud. I'm gonna open the file on WeChat.
Okay, go for it.
Was it the PDF or Word?
Word document.
Okay. So the price of admission to the price. So we have to find
So we have to find the total amount
so
of
we have
money
to
that
find the
is
people
collected.
from 5 and times 15.
Okay, the number of people that came in until 5 o'clock times 15, you're right. So that's what we had last time. This is the number of people that entered by 5 p.m. So I'm going to multiply that one by 15. Okay, and then I'm going to add what?
Yeah. That's closes 23. So from 17 to 23.
Okay, times what? So from 17 to 23, I need to multiply by what?
Multiply by 11.
Multiply by 11. Okay, perfect. So that should give us the admissions revenue, I'm going to call that. Revenue is money that you take in before your costs.
Uh,
Um, okay, and then this is with a calculator, so I'm going to go ahead and throw that in. So this is 15 times math 9 variables, y variables, function y1 in terms of x from 9 to 17. I'm going to close that and add 11 times math 9 variables, variables, y variables, function y1 in terms of x from 17 to 23. Okay, so our total revenue from emissions was $104,000, and 48.16. Okay, so that was $104,048 and 16.5 cents. And they said round our answer to the nearest whole number. So if this is revenue, should I round up or round down if you're a business?
because we cannot give you more money than you have, or
Right, so we need to round down. Okay, so this is $104,048.
48.
Were collected from admissions. during the day. Okay. We have a new function, h of t, is the integral from 9 to t of e minus L for 9 to 23. The value of h of 7 to the nearest whole number, h of 17 rather, to the nearest whole number is 3,725. I want to find the value of the derivative of h at 17, and then explain what the meaning is of h of 17 and h prime 17. So I'm going to jump over to Junho first. How can I find the derivative of h at 17?
Uh, we H.
Okay, so I've got a general form. We are deriving the integral from 9 to t of e minus L. So if I want to derive at 17, with my second fundamental theorem, what should happen?
D over
Okay, I'm deriving my integral. So I'm going to step up then step back down. So what would my final answer be? Let me go back from the formula quiz really quick. If you derive the integral from a to b of f of x dx, what would our answer be? Oliver, can you help us out with the general form? If I derive the integral from a to b of f of x dx from the formula quiz, what happens?
General, it's FB times prime B minus FA times prime A.
Okay, and so I'm going to go back to Junho. What will h prime at 17 be then?
E U of X time.
Okay. I think you're doing the general form, so I'm going to do that up here. So this would be e to the x times 1 would be the derivative of x, minus L of x times 1. Okay. Minus E9 times 0, minus L9 times 0, so we won't have to worry about the 9 parts. Okay, so that means h prime at 17 is just replacing these x's with 17. So h prime at 17 is e of 17 minus L of 17. Okay, and I'm going to throw that in the calculator. So this is e at 17, variables, y variables, function y1 at 17, minus variables, y variables, function y2 at 17. gives me negative 380.28. Okay, and then we need to write what these mean. So first, what does h at 17 mean? And then what does h prime at 17 mean? Anyone?
People in the park.
Okay,
Amusement park.
you're right. So h at 17 is the number of people in the park right now. At what time?
5 p.m.
Perfect. H of 17 is the number of people total in the park at 5 p.m. Then what does h prime at 17 mean then?
The number of people change.
Right. At which the people in the park is changing at 5 p.m. We can say that. The number of people in the park was decreasing at a rate of 380 people per hour at 5 p.m. Okay, any questions on C?
You need 200.
Actually, I might have copied this down wrong. Okay, that was 3. I just didn't write it right here. Sorry. I can see my calculator off screen. Okay. Last one. Give myself a little bit more space. At what time between 9 a.m. and 11 p.m. does the model predict that the number of people in the park is at a maximum? Okay, what has to be true when the number of people in the park is maximized?
The drive.
It should be equal to 0.
0.
Derivative should be equal to 0. Okay, so I can say h prime of t is e minus l. And then h prime at t needs to be equal to 0 when we are at a maximum. Number of people in the park.
And the second it should be
Okay, therefore e minus l should be equal to 0. And then we can solve for t. So in our calculator, just to set this up, I'm going to make a new function y3 that is y1 minus y2. And then I'm going to turn all of my other functions off. So just go over to the equal sign and hit that so that it's not highlighted anymore. Now the only function we are graphing is y3. Okay, now I want to know when this hits 0. And this is the number of people in the park. We know that the number of people in the park can go up to 6,000 at least. So when I set this for the window, I want to be able to see from 9 a.m. Until 11 p.m. So I'm going to go from 8 to 24 just to give myself a little bit of space. And go up to at least 6,000 people. Okay, so that should be good. I went down for 1,000 people and then up to 6,000 people. So if I graph this, we're interested in when this hits 0. Okay, so that is right there. So I'm going to calculate that 0. Left bound, okay, that's positive, and right bound, that's negative. So our 0 is at 15.794. I guess 15.795, because it's going to round up. $15.795. Or okay, so 15 is what hour?
Uh, 3 p.m.
Okay. So this is 3 p.m. And 0.79 of another hour. So I'm going to multiply that by 60 minutes. So this is, we're at 3:47 p.m. Okay, I'm not actually sure if we need that part. I think they'd probably take the 15.795. But if I was a business, I would probably want to write it as a time,
Okay.
just for people who maybe don't understand what's going on with the math. Okay, so let's score really quick and we'll see how we did. Okay, we had 6,004 people. We're getting the answer, so our integrated limits. That should be good. So we're okay with part 1. Limits, integrand, and answer. Set up for part 2, 15 times 9 is 17, 11 times 17 is 23. Okay, we got good. Then meanings and value. Okay, we've got negative 380. Okay, that's the same meanings. The number of people in the park for each of 17. Okay, and the rate at which people are decreasing at that hour. Okay. -1 if no reference to t is 17. Did we do that? Okay, we did, because we said 5 p.m. So we're okay. Okay, then setting your difference equal to 0 and getting an answer of, okay, they did leave it like this, but 15.795 or 15.794. Okay, we said 795, so we should be okay. All right, so for the homework, I have the rest of the free response from 2002. I want us to do question 1 and question 3 for today. Then we'll take a look at the second
Okay.
half when we come back on Tuesday.
Okay.
All right, thank you guys very much for coming, and I hope you guys have a good weekend.
Okay, you too. Thank you.
You
Thank you, goodbye.
bye bye.